So hello everyone. Today I'll be explaining about active, passive and at rest earth pressure coefficients. There is always a question that comes into minds of students like uh, what are these pressure and why the passive pressure is always higher, why the at rest earth pressure is in mid, and then why the earth pressure is the lowest. So, I mean, most of the people know what these pressure values are, and then, but they don't know conceptually what's their practical meaning is. So that's why I am going to explain that thing to all of you today. Basically, before going into that, I'll explain what exactly these three pressures are that are generally explained, and then I'll deep dive into it in order to explain their conceptual significance. So, first of all, as you can see, I have already written down some of the stuff here. So, when you can see, let's assume there is a retaining wall. This red color retaining wall, this is the initial state of the retaining wall, and then there is some backfill on one side which is at a height h, and there is some backfill on the other side, let's say at an height of oh, h2, and let's say this is your h1. So I'll just configure like this. Okay, so now when your retaining wall is not having any movement and it is at its original position, the pressure that the backfill, the lateral pressure that the backfill will exert on this particular wall will be your at rest earth pressure coefficient multiplied by the height of backfill. If the wall is having some movement which is away from the backfill, it will exert the passive earth pressure, sorry, active earth pressure, which will be your active earth pressure coefficient multiplied by the unit weight of soil multiplied by the height. And on the other side, when the movement of the wall will be towards the backfill, it will exert the passive earth pressure, which will be your Kp into gamma into H. Now, as you all might be aware with the basic concepts, your K naught might be 1 minus sine phi, Ka comes out to be 1 minus sine phi upon 1 plus sine phi, and your Kp comes out to be 1 plus sine phi upon 1 minus sine phi. So your Kp is the highest one, then comes a K naught, and the Ka is the lowest value that we get. You can also compare and get an understanding with respect to the signs, as the minus is coming on the top and plus is coming on the top for Kp and minus is coming on the top for K. Kp is more than K. Then again, these are the general uh, concepts which are taught to students in the university. But let's deep dive into the concept now. The active earth pressure, what exactly the active earth pressure is, as we have discussed, like the movement of the wall away from the backfill. Now assume a particular state where the wall has the movement away from the backfill. Because of this away movement, the initial state of the soil was something like this. Now the particular soil will have a tendency to move towards the wall. Because of this tendency to move towards the wall, soil will having some behavior of loosening or having some tensile strains into it. Because of that, soil will use its own shear strength to resist some of the lateral load, I would say. So, because of this shear strength, which is getting used to resist the lateral load, shear strength is getting mobilized and the overall lateral load on the wall is getting reduced. And this is what we call as active earth pressure. Active earth pressure is nothing but your lateral load when you are getting at rest condition minus whatever the component of the shear strength of the soil that is helping us in order to reduce the lateral load. So that's why the active earth pressure is getting reduced a bit as compared to at rest earth pressure. Now let's talk about the passive earth pressure. Now, because of this movement, the soil which is on the other side will have some compressive stresses. Because of these compressive stresses, the wall is pushing the soil on this side. Because of this push, the shear strength of the soil is getting utilized to push the wall. So as we have seen in the active case, soil was helping to reduce the load on the wall, the pressure on the wall. But now here, the shear strength of the soil is itself helping to push the wall, not to reduce the load. So because of that, the passive earth pressure comes out to be the lateral load at rest plus the shear strength component. So that's why the passive earth pressure is more than active earth pressure and the pressure at rest. So this is the overall concept. Why exactly there is a deviation in between these three values and why there is a difference in the pressure just by the movements. I'll also give a simple analogy to keep that thing into your subconscious. So let's assume a block. There is some block or a box you can assume which is having a weight of 50 kgs, and the coefficient of friction which is there in between the particular block and the surface is zero point 0.5. So now the horizontal force that will be required to push this particular block, move this particular block from its initial position, will be your mu into the vertical normal force. That will be zero point 0.5 into 50, 25 kgs. Now, in this condition, if you apply force which is less than 25 kgs, your block will remain at rest. This is something that you can compare with your rest condition in the earth pressure. Now, if you apply the force which is more than or equal to 25 kgs, you will either get active earth pressure or passive earth pressure. Now, whether you will get active or passive, that depends whether your soil is getting compressed or whether it is getting a loosening behavior or tensile strains generating into it. So, uh, if you just try to relate it with this analogy, you will also come to know K is the lowest, K naught comes somewhere in the mid, and KP is the highest one. So that's all for today. And if you have any doubts about this concept, just drop me your doubts into the comment box. I'll try to make a video on them. Thank you. Thanks a lot.